Welcome to Gunship.
Hi, those who don't know me, I'm Hugh Sanderson, responsible for the Cpp backend, but I think I've probably spoken to most of you in the last day or two. Unlike Nicholas, who didn't give the same talk as he did last year, today I'm going to give the same talk I gave last year, which is the state of the union of the Cpp target, or as we call a union in Haxe, an enum. The virtual machine, running in a virtual machine is something I'll get to a little bit later in this talk. So this talk, I'll talk about some of the highlights that have gone into the last 3.2 build. Three main points are the extended integration with native code, an improved CFFI, C functional interface, called CFFI Prime, and some extended scripting support built straight into the Cpp target. I'll also go over the promises I made last year for the year to come and talk about what was broken there, and then make some more promises that I'll break next year. One of the other themes is using the Cpp target both at a higher level and a lower level as far as more native and more scripting goes, and whether you think that's high level or not is, I guess, a matter of perspective. So last year, as far as native integration goes, I added the Cpp pointer class, which had a few little issues with the syntax to use it. It wasn't quite as nice, a little bit confusing as to whether you use the .ref or, but you could do some pointer arithmetic and integrate with some native classes, so that's quite nice. But this year I added two new features, the Cpp struct, which actually allows you to allocate a native class data on the stack, so there's no GC allocation involved with that. And this is used with the int64 class today, already in the compiler. So as you use int64s, they're not actually objects in the traditional Haxe sense, they're actually just sort of the raw int64 as you would find in the Cpp standard runtime architecture. And the Cpp reference is kind of to replace or augment the Cpp pointer. It's designed to hold a pointer to an external reference class. And the trick to making these work that I didn't come up with last year for the pointer is to actually hide the definition of these completely from Haxe. So as far as Haxe goes, it doesn't even know about the Cpp struct or reference classes. You use this native metadata to tell the Haxe compiler that that your classes live under a different name. So typically an external reference might be a rectangle. Here's an external class definition. The include that is here will bring in the include rectangle.h into all your generated code that actually refers to the rectangle class, which is nice so your definitions don't get undefined. This include meta is sort of goes hand in hand with the external definitions. So that's where you start. But then the trick here is you use the native metadata to make a new class. Here I've extended the rectangle class. By extending the extern class, it's like you get all the functions and the variables inside this new class. In the top one here, it's rectangle ref. So he'll have a x0, a y0, an x1, a y2, because he extends rectangle as far as the Haxe compiler is concerned. But as far as the Cpp compiler is concerned, the rectangle ref is the Cpp reference to the rectangle, and a similar thing for the struct. So the Haxe compiler just sees it as this rectangle class with an x0 and a y0, and you can have functions and stuff on that. But the Cpp compiler sees it as the Cpp struct of the rectangle. And here I can see another option, instead of extending the extern rectangle class, is for the struct to extend the reference. Or you could do the reference extends the struct. This actually lets you assign from one to the other without having to do any kind of casting. You can sort of go one way without a cast, but not the other way. So here's an example of the usage. I declare A as a rectangle struct, and what that's doing is making like a stack variable like you would in a real Cpp program. The equals null is to stop the compiler complaining about uninitialized local variables. The equals null actually just mem sets the struct to 0. So that's another thing about the structs is they have to be able to just be copied as memory. So if you've got any constructors and destructors in there, that probably won't work for you. So I take the struct, I set the x member to 1, I trace it, it's 1. I make a copy in the B, I set x equals to 2. The original value in the A is still 1, and the B is 2. So that's just showing that the struct will do a copy. And conversely, the reference will do a reference and not a copy. So I can create a struct, make a reference to it, and then when I manipulate the reference, it's the original data that is changed. As I said, this bottom line here where you can cast from the struct to the reference and the reference to the struct, you can generally organise the code so one of those directions is free and the other one requires the word cast. There's possibly something you can do with abstracts to allow both directions to be automatically cast, but you know, the cast isn't too onerous in this situation. So another thing you can do with the native structs is to provide a handler. Currently it's for handling the toString function, but potentially there might be other things in the future. And this is again done with the int64 class so that I can actually print, when you get one of these things and you add it to a string, it'll actually convert the int64 into the 1, 2, 3, 4, 5 to stick on the end of the string. And with your external classes, things like the properties still all work, and they're really really quite a flexible class, and fits in quite well with the general CPP way of doing things, Hxcpp. Another trick you can use with an external class is to use this the native metadata to rename your functions. In the Haxe code, it's problematic to have the function called new, or as it would be in C in this case, rectangle. But what you can do is use this native tag to say, instead of calling create, call new rectangle, and it will just pass the arguments you pass to create in. So that's the way of being able to instantiate an external class with a constructor. And similarly with the destructor, the function in CPP is actually called like ~rectangle, which you can't really type in Haxe. So if you just use the native extern, you can make a function called delete, and then when you call rectangle ref.delete, it'll actually really delete the original memory. Another thing that was added on after some discussion with some developers is when you include a file for an external definition, if you start with the /, it will include it relative to the .hx file, which is handy if you want to distribute some external classes and header files with your Haxe code, so that in, say, a library, then even on a developer's machine, it will know where to find the Haxe file without needing, sorry, the .h file without needing to specify a class path or include path in the XML. Another trick is to use this native metadata to turn a class static function into a global function. So in Haxe, you can't really just call a global function, but if you make a static function, give it the native name of the global function, then when you call this example here, some API do something, it will actually call the real C, some API do something. Including the CPP include in your Haxe code will also pull that CPP file into the developers end developers project. You can actually do this using the CPP class header metadata, but by putting in a separate file means your separate file has the .cpp extension and you get syntax highlighting, and you don't have to worry about backslashing your quotes, and it's just sort of a nicer way of grabbing the same CPP code and sticking it kind of next to your Haxe code rather than actually inlining it with your Haxe code. So the advantages of this kind of native integration, the struct is super efficient because it's a stack allocation. There's no GC operation or malloc operation. although it does work with dynamic. So if you pass one of these things off to something that takes a dynamic function, or you're calling it via reflection, it will actually box the struct value into a little memory box, pass it across through dynamic, and then unbox it at the other end. Which means that it will work with dynamic, although you will incur the boxing overhead just like you would when you pass an int or a double through that kind of process. And I think it allows for a more natural syntax. Once you've set your struct up, it's just going to go .x or .y. It's easy to use. You wouldn't even know you're using a native class. And actually, I think this is a better way of writing a small extension. So if you've just got a single CPP, some external functions you want to call, to actually stick it in a CPP file next to your Haxe code, rather than inlining or making an NDLL, is a pretty low friction way of doing it. If you have to make an NDLL of a small library, you end up having to do 4 architectures times 4 platforms, and it can be quite painful. So just having the end developer compile the extension is quite a nice little cheat. And along those lines, now this is just another point that has been added. You can get the CPP code generation to name its files with a .mm extension instead of the .cpp extension, which on Mac and iOS will let you call Object-C directly from inline. So it's actually compiled with the Object-C++ compiler. So that's quite nice if you need to integrate with some iOS extensions. So the next little piece of technology we'll talk about is the CFFI prime, C functional interface. It's built on top of the prim code that was in there from Nico, which is the technology you can use to build an NDLL and then be able to call these functions from Haxe. This is different from the native code I was talking about earlier, and I think now the decision as to whether you use an NDLL or native is not so clear. It's a bit of an engineering decision, and see what sort of preferences you like. An NDLL will, it encapsulates everything. It means that the developer who's using the NDLL doesn't need to have all the dependencies installed on their machine. They can just use it. So there are advantages in still doing an NDLL, even though you can do the native stuff a bit more easily now. So the new code is quite like the old code, except it's now got type safety from the Haxe side and avoids the boxing of the value types. So there's no GC allocations when you're passing an int or a string or a float into the CFI functions. And this also works on Nico and CPP. So if you go the native route, you cut out the ability to use Nico. And finally, it's now easier to actually write the CPP implementation from the C code. We'll have a look at that. So the key to it is to add the Java style string signature to the end of the load. So if you have a look here, the classic function add int III, which is returns an integer, takes 2 integers. You can see here in this call example, I passed in 2.0. You'll get a Haxe compile time error now telling you that the 2.0 float should be an int. So that's just used as a relatively simple macro to parse the signature into a strongly typed Haxe function. The call notation, I actually noticed Simon had put in 3.2 some abstract stuff to do calling, which I wasn't aware of. So maybe I can eliminate the need to type .call there. But this looks really basically like how you would use the old code, except it's strongly typed and it is using a direct function pointer. So it's about as fast as you can possibly get to get 2 integers into an external DLL. And if we look at the implementation, you couldn't get an easier implementation than that. It's actually your natural function. The define prime to takes over from the define prim to, except now it's more prime. And that takes care of the conversions from the value type to the ints on the Nico target. On the CPP target, it just goes straight to that int function. And the define prime to also takes care of the signature check. So if in your Haxe code you've updated it and at ints thinks it returns a float instead of an int, you'll get an error at runtime saying that this NDLL does not match your Haxe definition. So this is still relatively new. I haven't converted NME over to it yet, which is what I intend to do, which will probably battle test it a bit more, so there might be 1 or 2 quirks, but I think this is going to be like a more satisfying to use version. Dealing with the objects is still actually identical to how it was before. It comes through as the generic value type, and then you can query fields on that using the standard CFFI functions as you do today. So a third bit of technology I'd like to talk about is the Cppia subtarget for the Cpp. It stands for C++ Instruction Assembly. I think one of the main problems I have with the Hxcpp target is that you can't pronounce it. So I've come up with the one Cppia. At least you can say it now. I probably should have called it CPAX or something before, but yeah, I'm sick of saying it. Anyhow, so what is Cppia? It's a scripting target that will let you extend CPP classes using its built-in scripting facilities. It's run straight from the standard Haxe compiler, so it's got all the macros, and you can do everything you can do with the CPP target and the Haxe compiler you can do with the scripting target. And it runs as a sub-target of CPP. So you start your compile just like CPP, and you add the define D Cppia. So when you do that, the output directory that you'd normally get full of source code actually becomes an output file. Traditionally, would have the Cppia extension. In your Haxe code, both CPP and Cppia are defined. So if you've got a hash if CPP, that will trigger. So you might need a if CPP and not Cppia, depending on what you intend for. You can't use the native facilities when compiling to Cppia. Obviously, inlining a piece of CPP code is not going to make much sense. And the final Cppia bytecode that's generated is remarkably just like an AST dump. That's not a real accident there. You can do 2 versions of the bytecode. One is debug, and actually it's ASCII, and you can kind of read it, and you can see a while loop and a for loop in there. The release version just uses integer codes, binary integer codes for those sort of things, and it's much smaller, and it removes the debug line information. So here's an example: Haxe minus main test CPP to test CPP and define Cppia, and bang, you've got your test.cppia code. Actually, it's very much like Nico, and I guess that's also no accident. It's generates a bytecode file. When you go to run it, it consists of 2 components. You have to create a host program to run your script, and the client becomes a script. When you compile the host, you use the -d scriptable, and what that does is includes a lot of extra reflection information and the layout of all the classes, where to find the X variable within the point class, that kind of stuff. It also generates the execlasses.info file, which contains a lot of stuff which is currently not used, but particularly it contains a list of classes that are compiled into the host. And this is useful when you compile up the client code because it doesn't have to bother putting those classes that are already defined in the host into the client, and so that can save a lot of space. And when you compile the client, it'll actually look in your class path for this execlasses.info file to be able to exclude the files from the compilation. So to run it from your own program, you can just call the Cppia host run and pass in the script name. There is a basic host that actually ships today with the Hxcpp runtime, and you can use that by going hxlib run. So if you create a test.cppia file, you can just go hxlib run test.cppia. Generally, it'll run. Now, that doesn't contain, well, that just contains kind of the standard libraries. If you want to be more adventurous and put additional native code in there, you'll need to make your own Cppia host, and it's kind of really designed for you to do that. So build your own host with as much native code in it as you like. So, you know, we're game devs, so I like to have a sexy screenshot here. And this one just shows that the Cppia passes the 6,000 unit tests. So, find that to be quite a nice screenshot. So the integration, very tight, low friction because it uses the same GC code. So in the host, when you have the native files calling to native classes calling to native classes, there is no overhead at all. And when you have a native class calling to a script and back again, there's a little bit of overhead as it transfers the arguments across the stack. But apart from that, very low friction. And you can do all the things you would expect, like you can extend a class and override functions in your script, and you can implement interfaces in your script. You can pass closures from your script to your host class, and basically as you would expect it to work. So performance, there's no JIT at the moment, so it is interpreted code. But it does use strong binding, so it does all the name lookup at load time, so it's not doing name lookup at runtime, and this lets it target, you know, the position of stuff quite efficiently. So it's about the same as jittered Nico, and quite a bit faster than non-jittered Nico, and it's still slower than, you know, an optimized JS, which would have some kind of JIT system in it. But the cool thing about this is that you can move the boundary between the host and the client really easily simply by including your library in your host. So if you had a physics library, say, you could link your physics library into your host, and then it's running at Cpp speed instead of at script speed, and then your script would, you know, be used to, say, create the objects and respond to a collision callback, but wouldn't be calling any script code to update the position of the objects or you know, anything like that. So I think that's the key to actually not really worrying too much about the performance, is that you can set yourself up so that it's not such an issue. So, you know, the use cases for the scripting, to be able to compile without a Cpp compiler. So, you know, you can do that with Nico at the moment, but you can also build the host target for anything that the Cpp can target. So, you know, all the or your consoles, if you want to put them in there, or, you know, the Android, iOS devices, you can build the host onto those and then just script on top of that, you know, quite easily. It's basically designed for that. The other use case would be like a plugin, if you wanted to either have a level plugin in your game or a, you know, AI plugin in your game. You could have multiple versions of these scripts running, all implementing the same API, and then, you know, rapid reloading or hot swapping, or however you like to look at it. And, you know, a website script per page, haven't investigated that too far. That's really just a theory. So it brings me back to the initial slide. We've kind of got this VM inception. The Hxcpp is kind of a VM. You could be running a Cppia script, running an Hscript. On top of that, you could probably run the Cppia VM inside an Inscriptum inside a browser. And if you did that, I think you'd actually manage to make time stop. So I'm not currently in Go yet, and yeah, maybe even make time go backwards. Yeah. So all right. So just to review the broken promises from last year: numeric template specializations still not there. Fake interfaces, anonymous types still not there. Although with the Cppia being able to generate a class at runtime actually gives me a lot of ideas about how this actually might just work for the anonymous types without actually having to do too much as far as the compiler goes. Like, it should be able to do mostly at the runtime, I think, and that would remove a lot of the overheads associated with allocating a hash per object. Strong function typing is something I said was interesting, and I think with the CFI Prime now, that solves a lot of the problems with the NDLLs. There's still problems with closures and some functional programming that still goes via dynamic, and there's just still some work to do. But native Int64 is in there, running sweet. mostly, I guess, because it's now fully supported by Haxe, which I think is a great thing for the 3.2 release that maybe not much has been made of. And more native integration has happened. Obviously, there's a never-ending task, that one. So in the future, I'm going to look at some separating off the GC code to maybe make it more modular. So we've had some ideas about different or more efficient garbage collection implementations. So I'd like to be able to swap those around. I'd like to be able to have the GC being used by another Haxe backend, if there's the Gen C ones interested in it, or steal someone else's GC entirely, if I grab one from C# or something. I'm not sure what that would look like. Obviously, continue to evolve, as the language evolves, got to keep up with it, keep tracking it. Remove dynamic where possible. So there's still a few places where dynamic is used. There's enums, functions, anonymous types. So really just pulling back wherever possible and evaluate whether actually it really does need to be dynamic or is there something a bit smarter you can do. And then adding the JIT to Cppia is, I call it a stretch goal because there's a lot of code there. It's designed for it within mind. Like I've made all the ASTs sitting inside the memory in a format that was, you could JIT if you wanted to, but is something that I'm not sure what I'm going to get to. So I might try to run a quick demo here. Demo is of Academy, which is a Cppia host built from NME. Academy is a Hxcpp you can install today with the latest version of NME. It is simply a scripting host where I just made one file that I just imported all the HX files I found under NME. So that builds my host, that moves all the NME Haxe files into the host. Don't message me. With the Hxcpp, it comes with Windows and a Mac backend. It doesn't come with Linux at the moment because I didn't have time to properly test it. But you can compile to it with without a Cpp compiler installed on your machine. It's on the Android Play Store, so you can download the Academy host from Android today, and then run your NME programs on your Android device without the Android NDK or SDK or anything installed. You can't do the same with iOS because they don't want you programming their devices. They're way too cool for developers. They don't need us. So, yep, nothing coming from them. So I'll just start with just one of the NME demos. This is a memory thrashing demo, changing all the pixels. This one's been around for ages in the code base, and then running a little game of life. That's running CPP native. Running Cppia slower, as you can see. Does fewer iterations, so you don't get too bored. But it's not as fast, but it's not terribly slow. And again, the mitigation of being able to, for instance, if you were to move the game of life logic into your C code, and then it was just the script was only setting up the parameters for the game of life, then you would have something running at basically full speed. Just to compare to Nico, but this is Nico 64, which is unfortunately slower than Nico 32 because there's no JIT. But you can see it's a much closer crawl when on Nico 32. Just looking at the NME, the Academy application, you can install it on your Android device. You can then send the application to your device using the Cppia target and providing it with a deployment. If I look on here, it should have. Oops. It should have the should have the IP address. I also have just realised that there is a massive security hole when you're running on an open network, such as we are here, with this application. So I'm not actually, I'm just hoping it's new enough that I've got some security but obfuscation at the moment. But yeah, I wouldn't suggest leaving this application open on an open network at the moment. I'll have to add a pass key or something. Oops. So that's now running on the mobile phone. It's too hard to see. Well, let me try, you can do something similar with the iPad, even though you can't download this from the App Store because, you know, Apple are too cool for us all. You can get someone to compile it up for you if they've got a provisioning profile. So you can, you know, start the. I'll try running a different demo. Might be better. And this IP address. See if this is. Not the right IP address. Yep, so that's running the enemy stage video demo. You can see almost no time from typing the command to seeing the result, which if you've ever tried to battle with Hxcpp. All right, so questions?
Real quick, who here has used Nico and run into error std at module read? The one where basically your program is too big to run in Nico anymore. Yeah, so two questions. First of all, does Cppia solve that problem once and for all and murder it in its sleep? And second, when we get interactive Hxcpp debugging working in Flash Develop, will Cppia work with that as well?
Yes, yes. So it already goes through the same stack calls. So even though it's quite a different code path, it still calls in and checks in every line and checks the debugger, sticks its local variables into the debugger context. So yeah, it's fully integrated in that
sense. What about the memory overhead? Like with Nico, it's like if your application is big enough, it just won't work. What about Cppia?
Yeah, so there's almost no overhead above what you would have done if you'd written in C++. So there's the actual involved the size of your script. So, you know, a script file can actually get pretty big, maybe a couple of meg, big-ish, right? Not big by some standards. But so it's not really dependent on your data size. So when you create a Cppia class, it's the size of the Cpp class plus the extra fields, plus it's possibly got one extra field in case you do some dynamic stuff on it. So it is really very, very similar to the Cpp target.
So bottom line, you're telling me that I now have a fast virtual machine testing target that compiles in less than 1 million years, and it will work with the interactive debugger, and it will work it all with my massively large program.
Yeah, massively large, I can't promise, but
sufficiently
yeah,
large?
Theoretically, yes. Let's say that. Theoretically, yes.
Okay. Well, well done, sir.
Impressive. Two questions. First one is about hot swapping. Is it hot swapping? So if you have ability to have, for instance, you're running a script and have some actually running, and you just send another version of the script.
Yeah.
Is it something it's actually built for, or is it in progress or planned or something?
I wouldn't say hot. Well, it doesn't like replace any functions on existing.
Okay, so
right?
you just
rerun the script.
Yeah. You just restart everything. Okay.
Yeah.
Do you think it will be possible?
Yeah. So I mean, you can trace all the objects. So a matter of tracing the objects and replacing their vtable entries is certainly theoretically possible. Yep. Eventually,
I think we can get
maybe.
there, yeah.
But you know, because it uses the Haxe compiler, I guess you could send a delta or just update. I'm not exactly sure what that would look like, but you know.
Also regarding like failure application, you know, like null pointer exception and everything. Do you get the same like stack trace and all the like, or can it crash the script? What kind of security do you have in there, like for helping with daily development?
Yeah, so if you crash the script, it will, you know, the exception handling is the same. It does null checks on things. If you try to use a null object in debug mode, you'll be in the null object handle like you are in Cpp. If it crashes and you need to do native debugging, like actually debug the Cppia VM, the stack trace is actually kind of cool because it is the AST. So if you're in a while loop, your while loop will be represented in your stack trace. So it's not easy, but I use it. I debug like that.
Any provisions for infinite loops or those kind of things?
No, nothing like that.
Hi, the Cppia stuff is really awesome. I'm excited to see it and play with it. But I was actually had a question about the structs support. I know the C# target also has some structs, and is there any discussion on how to combine those so it's the same syntax? And
there's some discussion at the party last night, actually.
Oh, okay.
Yes and no. It's something we will discuss. Yes, C++ is a little bit trickier than the Java and the C# as far as the syntax goes, because you've got to either wrap the object. You've got to wrap the object somehow, because you can't just have a normal. You know, the C++ deals with smart pointers to objects normally, so to actually deal with like a normal object, you need to kind of fake wrap it. That's what the Cppia struct does, gives you the arrow notation as the dot notation. Yeah, there are some differences at the moment that aren't quite there. Like if you have an array of structs at the moment, it would be an array of box structs rather than one massive array of structs, which is something that will be fixed eventually, but maybe I'll see what Cal's up to and sort of combine efforts.
Yeah, a follow-up question for that. For targets that don't support it, just given that struct changes the behavior of the program so much, just even given your example, like the copy semantics, is there a way to emulate that on other platforms where it's still allocated on a heap, but you implement a copy?
This is something for Nicholas to work out how to do. Yeah. So I mean, because it uses the native. It's a native thing. It's CPP : : that's not going to work anywhere else. So,
sure.
Yeah, I think it would be a great addition. And if there was, if there was a more formal syntax, and then you wouldn't need to do any of this stuff, and it just sort of merged into the background, that would actually be nicer for everyone as well, I think. Yeah.
Thanks.
Okay. No, I was just commenting that we should talk about it. Merging efforts into this direction. And
yep.
Also about Cppia, I have, first of all, it was great, awesome. But what about, no, but what about statics? How do you deal with statics? For example, if I want to run a long-standing program, when it reloads, what happens to the...
Yeah, so the host variables will take preference over host classes over scripting class. If you try to load a Cppia class with one of the host classes involved, and say in your Cppia class you set a static variable to something in its initializer, it will get completely ignored because it just simply will not load a class that's already in the host. But if you say you have a new class in your first script, and you load your first script, statics will be there, and they'll be in the root list of the GC. If you wrote a second script that also has those statics, it will have its own copy of those. So when when it loads, if you've got class A defined in 2 scripts, each script will be referring to its own class A. It's basically the last loaded script will resolve the class names dynamically. So, does that make sense? But yes, actually there is actually no memory cleanup of the scripts. So if you load a million scripts, it'll just crash eventually because everything is still all there. I haven't really worked out when I can unload classes or unload states.
Oh, you can load once it's loaded?
No, not at this stage.
Okay, but it's great.
Yeah.
It's awesome. Thank you.
The internet has some questions for you. So Sven from snowkit.org asks, for Hugh, why doesn't CFFI prime use int hex function signatures instead of III from JNI?
Because it's easier to type, but yeah, I mean, you could actually use, because it actually, so it infers the type, whether to use I guess a question of taste. This is actually a pretty simple macro, you know, so you could do your own version of it if you wanted. And, you know, the underlying code would still be the same. In fact, it passes that signature into the CPP code, which compares it against the string III, and if it's not III, it will refuse to link. So ultimately, you will need to get to that string representation so it can check the signature. But yeah, you could define your own system. There's a macro for that.
The second question from the internet is, and I didn't catch this myself, so you might have already talked about this, but do you just change define prim to define prime and you get better performance, or is there more to it than that?
Yeah, so you would do that, but previously all your CPP functions would be referring to value, like all your implementation ones. Now you would only refer to value. Presentation is running in Cppia. Yeah, so this add int function here, if you look at this...
sorry, Lars, could you mention the name of the people who asked the question?
Yeah, the first question about the signature was from, I assume it was Sven, it was from the snowkit.org Twitter account. And the second question was Joshua Grenick of OpenFL, and I wasn't sure if you had talked about it earlier, but do you just define prim to define prime and you get better performance, or is there more to it?
So there's a little bit more to it. That's why I haven't actually done it yet. I needed it because it's a 3.2 compiler thing that's kind of new. But so if you look at this add-ins function, previously that would be value add-ins, value A, value B, and then you would do int val A plus int val B, allocate int. So it's really simplified what you're actually typing in the CPP code. So you need to go through and replace all the value calls that you would have in your CFFI with actual ints, doubles. There's a string, hx string, and then define prime 2. And then in your Haxe code that goes to use it, you need to call the new loader and pass the signature in as well. So you need to change the implementation, need to change the Haxe code, but it's all pretty easy. Like it's all formulaic. In fact, it's simple. So. Is it still Nico compatible? Yes. So this will generate the glue that converts the value into an int, calls your real function, gets a result, converts it from an int back to a value, returns to the Nico. So there's a little bit more in the Hxcpp. There's a test directory in there that runs through some of these scenarios. So if you want to jump in and look at some test code, compiles a simple project up for both Nico and Cpp and shows that it still all works.
Hi. I actually have 3 questions. First one is, are there any limitations on the Cppia target code-wise?
So mainly to do with the native calls. So you obviously can't call your native stuff like you can. I need to explicitly export some of the CPP runtime functions. Like the memory ones that you saw running in this test are like get byte array offset at I. So that some of those are in there. I couldn't guarantee that they're all in there. Like if you fully exercise the API beyond what the unit tests do, there might be some limitations there. And I guess we touched on it earlier about the unloading of the variables isn't of your script is basically a memory leak to some extent, so you couldn't run it indefinitely long. But yeah, generally the goal is to not be able to tell the difference between whether you're running Cpp or Cppia as a target.
Okay. Second question, is it possible to define a sandbox from the host for the client script?
Yeah, I know what you're saying. So this app runs as the context of the guys who installed it, and all the scripts can talk to all the other scripts, variables, and mess with each other if they have to. So there's not a lot of security going on there.
So there's no isolation of the script code.
Sorry?
Is the script running isolated or not?
No. So you've got to trust a Cppia like you would an executable. Like, don't download these from the internet if you don't know who's doing them.
And final question, did you compare the performance to PHP? Because I think that's an interesting comparison.
It's a good question. Haven't looked at that yet.
Everyone is telling me it's faster.
Yeah.
Okay, I hear from Kai, Nico is already faster than PHP.
Nico's faster. So as I said, it's comparable to Nico JIT for a lot of things. Yeah.
Okay, so this could be a real PHP killer then.
The question is actually about this slide. So this is like working with simple ints, and what about like some complex object?
Yeah, so the object code hasn't changed. That will come through as a value. So one of the signature types is just value, or O for object. You still got to go get filled by ID X and stuff like that. So that hasn't changed at all. Part of the NDLL is to isolate you from the actual implementation of the object. So that's still exactly the same. But this basically solves the boxing problem, and you don't have a boxing problem with things that are already objects. So I guess that's one of its main goals there.
Hi, I just wanted to understand it a bit better. So, are you having hosts that I can run enemy on different targets and put them on the targets and then compile from any machine and it will work on those targets?
That's right, yep. So the enemy has that deploy command in it where you give an IP address. The enemy host file has a protocol that listens on the socket and accepts the requests, and it's just FTP basically. Puts the files there and runs them. You can make up your own. You can read files from like a particular file on disk. You can set up the system kind of any way you like, but yeah. So if you want to use the Academy software that's there, that'll you download that on the Android Play Store now. Try it out.
Sorry, go from a Linux machine, say, to a iOS device.
Yeah, if you can get it installed on an iOS device, which you would need a developer license or someone with a developer license to do.
Right. Okay.
Yes, you can. But go buy an Android device. It's better.
Obviously, I'm equally excited about those possibilities as well. Can I take you back a bit and ask you about Hxcpp, because you spoke about it very briefly. What's the state of Hxcpp as a target?
Yeah, so I did a little bit of testing on it just for the 3.2 release, just to smoke test it. It did work. So I could compile NME to Hxcpp and get a rectangle on the screen. So not about audio, but yeah, it's certainly feasible. But
are you going to share that with everybody?
I'm not sure it's desirable. Well. Yeah, I've got some vague plans, but I'm not sure, once you're on a browser, I don't think you want to be running Cppia. I think you want to run JavaScript because it's going to run 100 times faster. I don't know, maybe not. Yeah, so I don't think it's the ultimate architecture for that yet, but it does allow the possibility. I mean, one of the problems with doing an Hxcpp app is that it ends up being, a 20 meg download on the web. But if you can use scripting on top of that, it means that your download can be on like a CDN and download it once as the 20 meg, browser can cache it, and then if you want to update the scripts, you're only updating a much smaller. I mean, these scripts are like 100K, there's not much to them. And that would be kind of almost like building your own Flash player in some ways, which, yeah, is a kind of an intriguing possibility, I think.
No more question?
Is the VM written in Haxe or Cpp code?
It's CPP code, and when you compile your thing, if you've used the -d scriptable, it brings those CPP files into your standard runtime, and they're just built in. So it's actually in the Hxcpp source directory under there.
I see.
Yeah.
Yeah, but the actual VM is written in CPP.
Yeah.
I was thinking about maybe trying it out on Java also, maybe, but.
The file format it is in with the, which is like the AST dump, you could re-implement it completely differently in Java, but run the same Cppia file. I mean, it is quite tied to the CP target, like, it uses dynamic where CPP uses dynamic, and, it's almost the same code. So there are some quirks, but it's not necessarily that different that you couldn't actually write a Cppia interpreter for any language. Yeah.
I see. Cool.
Just a small idea to bypass the IRS program. Like maybe you could submit some free-to-play game, and when you enter in the high score, you enter CPP as a username. It unlocks a hidden mode for developers that actually allows you to upload your code.
So build it in as a sub-game of another one.
Yeah.
Yeah. I mean, it seems like there's a rule in Apple which is just, if you can have fun programming it, we won't let it on the App Store. It's almost like, it's the anti-Cppia law kind of, I think. I don't know. Maybe they'll let it in. They do some programming you can do on their devices, but I could try spinning it, but it would be nice.
Thank you very much, Hugh. Good, thank you.
Welcome to Hxcpp.